what's on today's agenda? We're going to start by trying to talk about the problems that Kubernetes is actually solving. Then we'll jump in and talk about what is a microservice. And then we're going to talk about what is and why use a container. Then after that, it'll be what is Kubernetes and why use Kubernetes. And Sean is going to do a demo today on Octopus Shop. Sean, can you share a little bit about what you're going to be demoing today and what is Octopus Shop?
Yeah, Octopus Shop is a .NET Core application that we use for demonstrations and just showing how things work. It consists of four major components, which is the web front end, a product service, a shopping cart service, and a database project to do our migrations for us.
Awesome. Really looking forward to seeing that. And then at the end, we'll do some Q&A. Okay, so let's jump in. Let's talk about the problems that Kubernetes is solving. Traditionally, applications tended to come in a legacy, in a monolith. And monolith applications tend to be all self-contained. So like Sean was talking about the Octopus Shop, you can have a web front end, a shopping cart service, API, etc. That all actually came normally in a single application. And what this basically meant was it was really hard. It was massive, and what happened here is it led to long development and deployment times. Often you make a small change, you may add something to the API. What happens is you have to build the full solution, and along with that, you've got dependency hell. With that, you generally find that dependencies are as long as your arm. It's super inflexible and generally just pretty painful to work with, if I'm being honest. What this also meant was infrastructure costs were high. At the moment, you have to scale both horizontally and vertically with that monolith application, whereas what you can do with Kubernetes and containers and microservices is scale each of those independently. And often, what I found as well is in development, you would find that you would have team A working on feature A and team B working on feature B. And what this basically meant was you had that isolated development, and then you would do your quarterly release or 6 monthly rather than doing, say, a deployment per week, etc. And it had a big bang deployment at the end of the quarter. And often these were really painful, filled with errors, and generally no one was winning here. So what is a microservice? Sean, what's your definition of a microservice?
A microservice is just a small individual component of a larger application. Say for Octopus Shop, we have that shopping cart service. I mean, that's the only thing it does is the shopping cart.
Yeah, no, that's really well put. That's it. I mean, with that monolith application, it's all self-contained, and with a microservice, what you do there is separate your application out into many more services. They're all very separate and work in place of that monolith. The benefit here is they're highly maintainable and testable. You can just update the shopping cart. You can just update the database. You can just update, say, for instance, the API as well. So they are coupled, but fairly loosely, and they are independently deployable. And what this basically means is you can have distributed ownership. So team A can, own a particular part. Team B owns another part. Obviously, there's a bit of communication back and forth there, but it gives that flexible development and deployment. So you can pretty much deploy and develop as you require. And most of them as well, where possible, you want some backward and forward compatibility as well. So what are and why use containers? Containers are, you take your microservice and you effectively put it into a container. It's packaged software into standardized units for development and deployment. The benefit here is they're all very isolated. And another thing is you can also have multi-OS support. Containers, if you think of it traditionally, containers an application would sit on a virtual machine, and then with that, you've got the OS, and then say .NET, and then on top of that, your application. Containers only contain the dependencies and the code for your application to run. There is no OS. They share the OS kernel running as isolated processes as well, which actually has better security implications as well. One of the things I like about containers is that you can run them in isolation. So if you do have something that's got a memory leak, it doesn't take down everything. They're generally pretty small and easy to deploy. They tend to be tens of megabytes rather than gigabytes. And one of the benefits here is you have efficient hosting, and that's always going to be a good thing, because what you can do with containers is, say for instance, you own a food delivery application, and what happens is between 5 and 8 p.m. every day you have to ramp up your front end website. So you can go from one container to 100, for instance. And what that does do is, with the other side of things there, what you can do is scale them independently. So you can scale that independently from each other. So you don't have to scale everything up at the same time, and then use, there's compute resources which don't work. Another benefit is that you can run it anywhere and consistently. So what you can do there is multi-cloud. And one of the key benefits as well is that you can get greater density. So what you can do is you can effectively have, traditionally, even with virtual machines, what you could do is use, say, 150% of the resources on a VM host. With containers, you generally find that you're not using all of the CPU, so you can have a greater density. Like, for instance, we actually use AKS with Octopus. And what we can do there is, you generally find some customers are using it 70% CPU, some less so. And what that does give is a greater density and cost when it comes efficiency on cost. Okay, so this does kind of take me into the virtual machine architecture. What you would normally have is your infrastructure at the bottom. That's your hardware. That's your network stack. You've got your hypervisor, and then on top of that, you then got the guest operating system, and then the application sits on top of that. And with that, you can have many applications on the same virtual machine. The benefit with containers is you can take out the guest operating system. For instance, if you run something on Windows, how much can you really run on anything that's, less than 4 gig, 4 gig of memory, 100 gig in data. So if you think about it, if you scaled that up 400, say 100, that one node to 100 in a virtual machine architecture, that's a lot of data. So if you're going from 1 to 100 and you're using 100 gigabytes, that's 10 terabytes of data that you're using. And 400 gigabits of memory. So that's just something to factor in. And you can imagine the cost of that, the cost saving. So what you've got with the container architecture is you've still got the infrastructure there. You still need that networking stack. You still need the hardware for it to run on. You also have the operating system. You have then Docker, which is your runtime. And then on top of that, you've just got the application. So you're only needing to run your software and your dependencies in your containerized apps. So that takes us into Kubernetes. What is Kubernetes? It's actually been about for longer than I thought. It's been around for the last 5 years, just over 5 years, and that's obviously the proper release. It has been around in beta for quite some time. It's a portable, extensible, open source platform for managing containerized workloads. It's also a self-healing orchestration platform. Who doesn't like that? What you can do is with Kubernetes is with orchestration, if one pod dies, you can just spin up another one. With Kubernetes, you run it in clustered mode. So one of the things just to factor in there is if one of your nodes dies, which is how it works, think of it as like a VM host. If that dies, you can actually move the pod over, which is really great. You can run it on-premise, Azure, GCP, AWS, private cloud, and you can actually run it on your machine locally as well. So Kubernetes works in a cluster, and in each cluster you have a node. It's a worker machine managed by the master, and what you find is pods run on nodes, and nodes can have many pods. And also clusters can have many nodes. So we do obviously love a What's there? So in each one as well, you run a kubelet, and the kubelet is the primary node. So what you have a primary and then you have your secondary, but that's the kubelet is responsible for communicating between master and nodes, and it runs at container runtime like Docker for pulling container images and running them. So it's a graphical representation of a node. So as you can see there, this is a kubelet that's responsible for your node processes. You've got a few different pods there. As you can see, each pod has a container. And what you'll find is if you look at the bigger picture, in that cluster, you also have multiple nodes. So you've probably saw that I mentioned a pod. What is a pod? A pod is something that Kubernetes creates, and it includes resources such as shared volumes, networking such as the cluster IP, container information such as image version, ports to use, etc. Pods are effectively a logical host and contain more than one container. So say, for instance, you have a container that has a database, you can put that in there. You can have a container with your application. You can have another container for another service as well. And what that does is it includes apps and data containers in a single pod. So what you're doing there is, say for instance, traditionally, if you had it as a virtual machine, it's a bit like installing app A, app B, and say, for instance, a database. But what it does do is it takes away the operating system aspect. It does share the same IP port space and are co-located and co-scheduled. And what that means is, say for instance, you have two different web apps. You will need to run something on a different port, but Sean will show you a bit more on that later. But effectively, pods are the atomic unit on the Kubernetes platform. Okay, so this is another graphical representation of what is a pod. So you can start over on the left-hand side. Very straightforward. You've got a single container. You've got a one-to-one relationship there from containers to pod. As you go, they do get a little bit more complicated. You can add in some storage. Then pod 3 is another container, and then pod 4 has 3 separate containerized applications. They can be in varying sizes as well, and then some volumes as well. So why would you use Kubernetes? Why wouldn't you really? Everybody's going on about it. It's the hottest thing in technology, I think, at the moment. It's fault tolerant, which is great. Obviously it's very modular, so you can, use as required. It really gives you easy orchestration, scaling, and elasticity. One of the main benefits is it's vendor agnostic, which means it's multi-cloud. You can run it in a higher density, which means it's great for software as a service. I will talk about that in a little bit, because we use Octopus, AKS, and Terraform predominantly for Octopus Cloud. Another key bits here is you've got rolling updates. You've got zero downtime deployment. So think about it as like blue-green, for instance. You can switch. You can say, for instance, you have container version 1.0. You want to deploy 1.1. You spin that up, and then you switch it around at the load balancer level. So why would you use Octopus for Kubernetes? Well, we use Octopus for Kubernetes, which is really cool. But what you've got there is first-class variable management, environment modeling. You've got dev, test, pre-prod, etc. Container versioning built in. And one of the key things that I like about it is multi-tenancy. So I'll talk about cloud and about Octopus Cloud in just a moment. But we use multi-tenancy there to spin up all of our Octopus Cloud instances. And you've got integration with multiple container registries such as ECR, ACR, Docker Hub, and also custom Docker registries as well, like Sean's using Nexus Hub later on, which is really cool. So we've got a use case here, which is Octopus Cloud. Just to give you an idea, it does use Octopus Deploy, multi-tenancy, and Azure Kubernetes service. We have over 1,500 containers at any one time, generally over many clusters across the world. We've had over 8,000 instances of Octopus in the last 12 months. One of the things that I really like is the spin-up time. One of the, when you think about it, see, we did used to have it on AWS RDS with EC2 instances, but that took actually quite a long time to be provisioned. With Kubernetes, the spin up is about 2 to 3 minutes. Sometimes it's faster as well. By all means, test it out. If you are interested in Octopus Cloud, you can go to octopus.com and then sign up for a free instance. We give actually free instances to anyone who signs up with up to 10 deployment targets. One of the cool things is we are actually on 3 regions, and we do have more coming as well. We have a region in Australia, we have a region in Europe where I am, and we also have a US region as well. One of the key things is it's fully managed, and it does save a lot of money as well. Because one of the things that with the greater density that we can run Octopus Cloud on, we actually have a blog on the 100K AWS bill, and I definitely check it out. It will be in the follow-up email, but we're seeing that a price reduction of about 90% when using something on AKS on Kubernetes, which is really great. But the key thing here is if you're doing software as a service, then certainly look at using Octopus with AKS or EKS, etc.
So thank you very much, Derek. That was an awesome primer into Kubernetes. As you can tell, Kubernetes is a really dense subject. There's a lot to it. I wanted to explain a little bit about how this demo is going to go. It's going to be different than our traditional 101s, especially the getting started, where we typically go through the process of setting up the project, setting up the targets, and setting up the environments as well. I've already gone ahead and created the project environments as well as some project variables, so we don't have to waste time typing all of those in. I wanted to talk briefly about a Kubernetes target in Octopus Deploy. The traditional sense of an Octopus Deploy target is a tentacle that's installed on like a virtual machine or a physical machine somewhere that you deploy to. With Kubernetes, you don't install the tentacle on anything. In fact, you actually just interact with the Kubernetes API. So essentially, you're only providing instructions. So for this demonstration, I did create a Kubernetes target in AKS for us already, and I did that with a runbook that I'll just briefly walk you through. So I called it create K8 cluster. And the first thing that it does is it creates a resource group, and I do that mostly to keep things nice and tidy for all the resources created for this demonstration, so that when I go to delete the resources, I just delete the resource group and it takes care of everything for me. I don't have any leftover components that I might accidentally be paying for. Then I get the Kubernetes version. The Kubernetes version can vary by region. So I wrote a little script to go out and query the supported versions of Kubernetes in the region that I'm in, grab the highest version, and then stuff that into an Octopus output variable. The next step is to use an ARM template. Now, Azure has done a fantastic job in that you could go to the portal, you could start to design the resource or resources that you want, and then before actually creating them, you have the ability to download the ARM template. So you can do this automatically using automation, and that's what I've done. I've just put in a couple of variables, and here's that Kubernetes output variable that I showed you. And we can touch on the ARM template later. I was going to try to quickly go through this. Lastly, we have a step template that one of our colleagues created to register the cluster to the instance. And that was because we've done a lot of these and we kept copying and pasting code. So they had the forethought to put that into a step template just to make it easier. All right. So now that we've shown you, one thing I wanted to mention, on our samples instance, which is where I'm at right now, we do have a ton of different runbook examples that you can see how to use them. So I'd recommend going to check that out as well. So let's define our process. So OctoPetShop, as we explained before, consists of the 4 major components, which is the web front end, the product service, the shopping cart service, and the database project that uses DBUp, which will create the database if it doesn't exist and perform our migrations for us. Now, we'll also need a database server to run this against. So as part of this demonstration, I've included the deployment of a SQL Server container. So we're going to click on Add Step. And right away, you'll notice that Kubernetes itself has a an entire category devoted to it. And when you click in here, you can see that we have 8 built-in step templates, as well as a few community step templates that people have created to go along with it. For this demonstration, we are going to be using mostly this deploy to Kubernetes containers step. So I'm going to click on add here and call deploy SQL Server. And as I scroll, you'll be able to see all the different options that are available for a deployment for Kubernetes. I've already created a variable for the deployment name, so I'll go ahead and select that now. For the most part, I'm going to leave a lot of this as default because this is just a demonstration. I want to show you exactly what could be done. So I'm just going to have one. I don't need multiple SQL servers at this point. Normally, when you create a database server, you would create a persistent volume to go along with it. For this demonstration, we're not really going to worry about persisting data if the container is destroyed, so we're not going to create a persistent volume or a persistent volume claim. But I am going to go ahead and select the container, give this a name. And for this container, I'm going to be pulling from Docker Hub. So I'm going to search for the image I want to use. And here it is, the SQL Server for Linux. I need to expose a container port so that we can use it. So we'll call it SQL Server port. And this is the standard one of 1433. There are 2 environment variables that are required for this container to actually run. So let's scroll down to the environment variable section. And again, you can see that there's just a ton of different options you can choose just in the container section alone. So here we are, environment variables. So I'm going to click on add environment variable. The first one is accept EULA. And we're going to hard code that to yes, because why wouldn't you accept EULA? And the next one is the SA password. And I've stuffed that into a variable so that I don't mistype it. Need a little octostash in front of that. Scroll down through the rest of this just so you can see what's available. We are essentially done with this container, but just wanted to show you the sheer amount of options that are available for the container alone. Okay. Along with this container, we do need a cluster IP service to go along with it so that other pods can talk to it. So we're going to scroll down to the service section of this form. And we're going to give our cluster IP service a name. Now this name is pretty important so that, because this ends up being the DNS name so that other pods can find it by name rather than having to know its actual IP address. And since we exposed the container port, we need to expose the service port as well. So we'll go ahead and do that now. And use the same port of 1433. Okay. It's going to scroll down the one time so you can see that all of the other different options that are available in this form. There's just a ton. Okay. I'm going to add our next step. This is going to be our web front end. So again, I'll choose Kubernetes and the deploy Kubernetes containers. Call that deploy web. Oh, I think I forgot to choose this on our previous step. So let me go back and make sure I did that. I did not. So there we go. That's required. All right. We'll continue here. We'll go down to the deployment section, and I'm going to give this deployment a name. And one thing that's going to be slightly different than all of the other ones that we're going to do is I'm actually going to add a label to this, and I'll explain why this is required later. I'm going to give it a name of components. and a value of web. We'll scroll down to the container section here. And this container is going to be pulled from our private repo of Nexus. Let's give it a name here. So use our Nexus container feed here. And select our web container. Now this container needs to expose two different ports. It's running the ASP.NET Core web application, which is running the Kestrel server, which has a default port of 5,000. So we're going to set that to 5,000. And this application automatically redirects to HTTPS. So we need to expose that port as well. And that one's on 5,001. The web front end does need to know the URLs to the two services that we're going to be adding in a minute. So we need to add a couple of environment variables for this. So click on an add environment variable. Paste these guys in here. So there's the product service. And then we also need the shopping cart service as well. Okay, now that we've added those environment variables, we are done with this container. And this particular deployment doesn't need anything else, so we can go ahead and click on adding our next step. And now we're going to add the product service. So again, we'll choose Kubernetes and deploy Kubernetes containers. So this will be the product service. Choose our same role. Give this deployment a name. And now we're going to add the container. So the rest of these are going to exist on our Docker feed, so we're going to choose that for all of them. This has one port it needs to expose, which is an HTTP port, and it's configured to run on 5011. This container also needs the database connection string, so we need to add that as an environment variable. So let's scroll down to the environment variable section. Add the name and its variable that I've defined inside of our project variables. Okay, we are done with the container. This one does need a cluster IP service, so it can be found. So let's scroll down to the service section. And we're going to give our service a name. And expose that same port that we did for the container. Okay, we are done with the product service, so let's move on to the shopping cart service. Following the same steps. Choose the same role. And we're going to give this deployment a name as well. And this, I'm going to go down to the container section and add the container. Choose our Nexus feed, search for our container. And shopping cart service. This does need to expose one port. And this runs on 5012. And just like the other service, it needs to be able to connect to the database, so we need to define one environment variable for that. I think I still have the value in my clipboard there. Okay, so we're done with the container. Just like the other service, we do need to have a cluster IP service so that it can be talked to. So let's scroll down to the service section. Give this service a name. And then also expose the same port we did. So that's the HTTP ports. All right. So far, we've created our SQL Server, our web front end, and our two services. The next part that we needed to add was the ability to do our database migrations. This is a slightly different type of thing in Kubernetes in that it's a console application that's designed to run, then stop. Usually Kubernetes containers or Docker containers in general are supposed to keep running. So this is slightly different. So we need to add a different step template. So we're going to click Add Step. And I did want to point out that I actually haven't had to save in any of these steps that I've added. This is a relatively new feature in Octopus Deploy that it saves. You can do a save all at once versus having to do a save per step. In older versions, it was a save per step. So that was something that could be quite cumbersome at times, especially if you have large deployments. So let's click on Kubernetes. And we're going to choose Deploy Raw Kubernetes YAML. Okay, call that DB up. And within this step template, you have two different ways that you can supply the YAML. You can actually have it within the step itself or defined inside of a package. We're going to add this to the step itself. And go ahead and paste in the YAML that's required for this. As you can see, it's a kind of job, and that is designed to run, then stop, and Kubernetes knows that. We've defined where to find it from our Nexus feed, as well as given it the connection string that's required. So we are done with this. Now, the one thing we haven't done is given the ability for the internet to talk to our web front end. Now, there are two ways that you could do this. You could do this with an ingress controller or a load balancer. For this demonstration, we are going to use a load balancer. So I'm going to click on Add Step again, Kubernetes. And since I'm not deploying a container, I don't need to use this, but I can use this Deploy Kubernetes service resource. So if I click on Add here, deploy load balancer, and choose our same role. And I didn't give this one a variable, so we'll just call this web load balancer. And I'm going to choose the load balancer type. For the cluster IP and the load balancer IP, especially when it's an external, Azure is going to do this for us, so we don't need to specify what that IP address is, so we can just leave that alone. But we do need to add a couple of service ports. So I'm going to have the load balancer listen on port 80, but route to 5000. And if you recall earlier how I mentioned the application is automatically going to redirect to HTTPS, so I need to add that port as well. And that was on 5001, and we're just going to leave it at 5001. All right, our deployment, oh, forgot one thing. We do need to tell the load balancer what pod to connect to. So that's where that label came in, where I added that to the web front end. So we're going to use a selector label. So we're going to add this, and we're going to give it the same name and value so that it knows what to attach to. Okay. Our entire process is complete. So now we can kick this thing off and let it rip. We're going to create a release here. And deploy to development. So that was actually relatively simple. What did you think, Derek?
Well, that was, considering how complex Kubernetes is to learn, I thought that was really great. Because one of the things that gets me about Kubernetes is it has so many layers. It's a bit of a layer cake, Sean, I think. And I think what you have just shown there is really good in that it kind of really helps cut through that cake of, obviously the layer cake and get there much quicker.
Yeah, I like your play on words there, Derek. Layers.
But yeah, it does definitely seem to make Kubernetes much simpler. Because that's the thing is it's great. Kubernetes is a fantastic platform, but it is quite. I think you said earlier on, it's quite dense. And it is. To be honest, it's funny though because I don't think it's massively different when you get. You still need a virtual machine, etc., to run this on. It's just obviously the abstraction of the operating system is at the node level.
Yeah, and when you talk about virtual machines and whatnot, let's go take a look at what was actually created for us in the Azure portal. So as I explained before, I create a resource group for this, and it's aptly named Webinar KH Octopus. If I click into this, I only see one resource. I see a Kubernetes service, and that's it. And if you're familiar with Kubernetes, you know that there's a bunch of other things that run Kubernetes, the different VMs and whatnot. So when I was looking at this, I was wondering where all those things actually went. And that's when I noticed that there was this other resource group that I didn't create. And when I click into this, I find all those other things that Azure just creates for you. And that's one of the really cool things about that managed service is that you don't have to know all that stuff in the background. It's going to create it for you. And it just makes it simple.
Yeah, definitely. And it's funny because you still have that public IP address, you still have the virtual machine, you still have that root table, which is really great. Because that's the things that, you still need a load balancer for your Kubernetes pod to run.
That's right. Let's go check on our deployment here. Looks like it's got the SQL servers done. So let's take a look at what that looks like in the interface of Kubernetes here. So if we click on this, we can see this workloads section here. And we can see that our SQL Server deployment has been complete and it is up and running. And currently it's working on the next one.
Yeah. I really like that. I have to say this. Obviously this is things that I've played with Kubernetes in the past, and obviously as part of our webinar, I had to go do a bunch of learning, and it's great to kind of see how Octopus really kind of takes you through and makes it much simpler. And the thing is, as well, is like obviously you can provision this. Like you've done the provisioning of the infrastructure using ARM, which is Azure Resource Manager templates using an Octopus Runbook as well. So not only can you spin up deploy the application, but you're also spinning up the actual infrastructure for it as well. And it's super fast because I think we've done this in the past, and you're roughly talking about 6 minutes to deploy the infrastructure, and then also about another 6 minutes to deploy the application. So you look at 12 minutes to actually take you through to deploy the infrastructure, then the application. And it's not just a straightforward application either. What you can, with that, you're also doing it, you're doing that SQL database, you're doing the web front end, you've got the product service, you've then got the shopping cart, and then lastly, the database as well. So, it's not just a web app and a database, it's fairly complex.
Yeah. And I mean, if you really want to, if you're new to Kubernetes, I would definitely recommend taking courses on like Udemy or Pluralsight. I personally took the one on Udemy, and it definitely demystified how all of this works. Containers, I wouldn't say I'm an expert in the subject, but at least I have a much, much, much better understanding of how it works and how it fits together.
Yeah, I think there's lots of really great. I think there's a lot of really great resources out there like that. Like you said about Pluralsight, there's Skylines Academy. I mean, there's so many great and free resources as well. Like for instance, I've done a lot on Microsoft Learn as well. So if you are in that Azure side of things, then you can use Microsoft Learn for free. It'll teach you a lot of the basic concepts, Docker, containers, all the way through to Azure container registries as well. So there's lots of really great resources out there for free and paid for as well. You've done some on AWS as well, haven't you?
I've done some things on AWS. I've found that the permissions on AWS are a bit trickier to work with and getting something to work well. So I've mostly used Azure or a local instance for my Kubernetes playing around.
Yeah, because with Azure, this is all happening with a service principle, isn't it?
It is.
Excellent. Yeah, I have to say, because obviously you can get very granular with that. I have to say it does tend to make things pretty straightforward.
It looks like it's getting pretty close to being done. So if we pop back over to Azure and do a refresh on our services, we can see all the different workloads that were being deployed. The one thing that you're not going to see in this specific interface is that DBF job. That's mostly because it's not a workload in the traditional sense. It's just a job, and this is exposing deployments. Let's pop back over here soon. Oh, we have a failure. The demo gods were not kind to me today. Let's see if I can figure out what happened here. Did I forget to? I forgot to add the role.
That'll do it. That'll do it. We've all been there before.
So we are going to create a new release. And we're not going to deploy the entire thing. We just need to deploy these last two steps.
Yeah, it's really great. I like that about Octopus is you don't have to deploy everything all the time. So there's good management there. But obviously one of the things you can't, obviously with Sean showing this, you can't redeploy version 0.01 again because unfortunately it snapshots it. So that's just something to factor in when you're, sometimes you get it. Sometimes you actually get like a timeout or a problem with the API as well. So,
yeah. Unfortunately. But the one thing that you can do is if you make changes to variables, you do have the ability to update the variables on an existing snapshot, and you can redeploy that one if that was all that was done.
There we go. So we've just got the load balancer to go. I remember when this used to take 3 months, Sean, and and you're doing it in 12 minutes.
Yep. Maybe 13 minutes with my Staffo.
Yeah.
So if we click on our services, we can see all the different services that were deployed. We can see that these here, as I said, are actually going to be the DNS entry names that are going to be used when the different components that talk to each other run. So let's see if this is all ready to go. Oh, I hate staring at loading. So did you learn anything new here, Derek?
I think, yeah, definitely. I think I've probably learned more, obviously, over the time that we've spent together both doing it. But I think there's a lot of really great stuff here. I think this will really help out. And I really like in the Azure portal where it shows you the port mapping. So you've got like port 80 to obviously your local ports, and obviously you're doing NAT in there as well.
Yeah, absolutely. Let's give this one more try before here we go. We can see that it's already redirected us to port 5001. It is using a self-signed certificate, so this is normal. This is just for demonstration purposes. And here we go. We have Octopus deployed in Kubernetes.
Awesome. That's really great. Thank you very much, Sean, for that. That was, and obviously one of the things I just want to point out is we'll send over all these resources that Sean has been using today. So we'll actually, you can log on and download the containers for each of those, and then use this video to actually run through and do it yourself in Octopus. Okay, so it's Q&A time. Let's say we've got, oh, now this one's a really good one. Here goes, there's quite a bit to it, Sean. Any thoughts on what a developer's individual setup should look like? E.g., would you recommend using Kubernetes locally? If so, how to avoid duplicating all the Octopus process steps you just manually created? Seems what would be useful is the underlying YAML for those Octopus deploy steps to be stored in Git, along with the source code, and also used by developers locally. There's quite a bit to that one.
There is quite a bit to that one. And with, I see your point. I'm going to actually pop back over to my screen real quick and show you something that I didn't show you during. So if we go back to process here, when using this container step, we do have the ability to go and see the YAML that was created for each of these different sections. So this was the deployment section. And also we do have the service section. We can do the same thing here. We can see how that was created. So if you did use this form and you instead wanted to use the YAML, you could just copy and paste those. And instead of using this step template, you could use that deploy YAML step template, have all of those YAML files in a package, and do it that way, and say use this file in a package.
Yeah, that's awesome. Can you source control this as well?
Can you config as code is coming. It's on our roadmap. It's up the top of the hill, so not quite yet. But you could source control if you just had just the YAML and decided to use the YAML approach. You could, yes.
Yeah, I think that's really good. And obviously, you can use Minikube locally on your development workstation, but along with that as well, you can also use cloud providers as well. Like quite often what I see, Sean, is when people are developing on Kubernetes, you'll likely still want something in AKS that you can spin up each day, deploy your source code to, test it. But Minikube is also something that you can install locally using Homebrew if you're on a Mac or a Linux box, and then also with you can also install it via Chocolatey as well.
Yeah, there's also Docker for desktop that can run Kubernetes.
Yeah,
that also helps with local development.
Yeah, that's always a good question because it's you with the development side of things, you kind of want it to be as close to production as you possibly can.
Oh, absolutely.
So yeah, I think we've answered that one. That was really good. Got another one in the demo. When deploying version 0.2, will the version 0.1 containers be removed? If so, does that happen on a step-by-step basis in the Octopus process? If you wanted to deploy all version 0.2 components and then stop health check and have rollback option before moving to the new version. So yeah, that's quite a question. Obviously, I think with that, it doesn't automatically remove any containers. It would only redeploy the new version of the containers. Would that be correct?
With the 0.2, when I deselected all of those other steps, it didn't run any of those other ones. So depending on the options that you chose, you could have the rolling deployment type or the recreate option on those within this step template. So it didn't do anything with them at all. It focused on the 2 steps that I had remaining.
Awesome. We have another one here. Are you aware of any methods of adding custom options within the container section within the deployment template?
Custom options. That's a good question. Let's see here. Let's go down to, oh, I missed it. Where am I? containers. Containers. I don't believe I saw one in this step templates.
That's one thing is there's so many options. It's very customizable. I started jumping into taints and tolerance, and it started actually it was very complex, but it's really cool.
Yeah, I'd have to get back to you on that one. I'm not seeing anything for custom options other than maybe overriding the command on the container if it has that ability.
Yeah, awesome. You can reach out to advice@octopus.com if you to be a little bit more specific and see if we can help you there. Is there any demo documentation available on blue-green Kubernetes deployments? Because that's something that we do by default, isn't it, Sean?
It is. And does Matt Casperson have one of those blog posts out? I'd have to go back and look.
Yeah,
I think
Matt's got so much documentation out there. So what I do there is check out octopus.com/docs. Again, if you have a look around, there's loads of great information. Obviously, with Kubernetes, you can have a rolling upgrade. You can have blue-green as well. What are the other options as well, Sean?
These are the options that are available. It's recreate, rolling, or blue-green. So,
yeah. So to ties back into some of the previous question as well, you can also, if you selected recreate deployment with that new release, then that would have then went and just done the full. But obviously, as you deselected it, you didn't want to use that option. So that makes sense.
Yeah.
Okay. So one question is, can you use GCP with Octopus for deployments?
Yes, we do have on samples. If I pop over to the Kubernetes, this deployment orchestration rundown here uses all GCP to deploy Octopus Shop.
Yeah, so you can go to samples.octopus.app and actually log in as guest and see all of this going live. You won't be able to do the deployments, but you'll be able to see all the scripts, etc. So obviously check that out. Can you use Helm with Octopus?
You can use Helm. Pop back over to the webinar here so I don't mess with anything over there. And process. In the Kubernetes section, there is at least one Helm that you can use. And I know it can be used. I haven't used it personally, but I do know that other customers have used it.
Yeah, awesome. Another one as well is, does it work with OpenShift and Rancher?
It does. I've recently done 2 blog posts on both subjects that you can use Octopus Deploy with both Rancher and OpenShift.
Awesome. Right, I think that's all the questions. So let's wrap this up. Okay, so thank everybody for attending today's webinar. I hope you learned something. Just one of the things to be aware of, we do have some test drive virtual machines. So if you go to octopus.com/test drive, there are virtual machines that you can download and just get running straight away. One of the things just to be aware of is on the 2nd of September, we've got another webinar on Octopus 101, server provisioning in AWS with CloudFormation and Runbook automation by Adam Close and Michael Levan. Then on the 16th of September, I'll be back with Raygun.io talking about empowering your development team with real user monitoring and automated deployments. We do have a short feedback survey that will open at the end of today's webinar. We would love it if you could take just a couple of minutes to complete that. It really helps us plan future webinars as well. Sean, I thought your demo was fantastic. I really enjoyed it. And everyone else, have a great day, and we'll see you in a couple of weeks.